Hello! In this video, we are going to prove the following theorem. There are no integers x and y such that x squared plus y squared is equal to 2023. Now, to prove this fact, we are going to be using modular arithmetic. So we have the following definition. Let a and b be integers, and let n be a positive integer. We say a is congruent to b modulo n if n divides a minus b. Or put another way, a and b differ by a multiple of n. Now, congruence modulo n is an equivalence relation. In other words, given any integer a is congruent to a modulo n. If a is congruent to b modulo n, then b is congruent to a modulo n. And also, if a is congruent to b modulo n and b is congruent to c modulo n, then a is congruent to c modulo n. Some other properties about this relation is it is compatible with addition and multiplication. And what I mean by that is the following. If a is congruent to b modulo n and c is congruent to d modulo n, then a plus c is congruent to b plus d modulo n, and a times c is congruent to b times d modulo n. Another property about this relation that we're going to be using is the following. Given a is an integer and n is a positive integer, then there is a unique integer b, such that b lies between 0 and n minus 1, and a is congruent to b modulo n. Okay, so in proving this theorem, we are going to be using modular arithmetic. In particular, we're going to be working under mod 4. So in this result, taking n to be 4, this result says, given any integer a, there is a unique integer b, such that b lies between 0 and 3, and a is congruent to b mod 4. Okay, so now let's get into proving this theorem. To prove that there are no integers x and y such that x squared plus y squared is equal to 2023, we are going to prove for every pair of integers x and y, x squared plus y squared is not equal to 2023. So, to prove that, let's give ourselves two arbitrary integers, x and y. With this arbitrary pair of integers, we will show that x squared plus y squared is not equal to 2023. Now, we're going to be working under mod 4. Now, the idea is, according to this result, we'll take a to be x. Well, then in that case, there is a unique integer b that lies between 0 and 3, and x is congruent to b mod 4. Now, b is either equal to 0, 1, 2, or 3. So this tells us x is congruent to 0, 1, 2, or 3 mod 4. Now, given x is congruent to one of these four numbers, mod 4, what is x squared congruent to, mod 4? Well, if x is congruent to 0 mod 4, well, since congruence, since this relation is compatible with multiplication, if x is congruent to 0, it follows that x squared is congruent to 0 times 0. And 0 times 0 is equal to 0. So this shows x squared is congruent to 0, mod 4 in this case. So then what happens if x is congruent to 1, mod 4? Well then, x squared is congruent to 1 times 1. 1 times 1 is equal to 1, so this shows x squared is congruent to 1 mod 4 in this case. If x is congruent to 2, then x squared is congruent to 2 times 2. 2 times 2 is equal to 4. but 4 is congruent to 0 mod 4, because 4 and 0 differ by a multiple of 4. So in this case, we see x squared is congruent to 0 mod 4. Finally, we consider the case x is congruent to 3 mod 4. Well, then that implies x squared is congruent to 3 squared, or x squared is congruent to 3 times 3 mod 4. 3 times 3 is equal to 9, but 9 is congruent to 1 mod 4, because 9 and 1 differ by a multiple of 4, namely 8. So this shows x squared is congruent to 1 mod 4. So what these cases tell us is, no matter which case we have, it always follows that x squared is congruent to 0 or 1 mod 4. In a similar way, we can obtain that y squared is congruent to 0 or 1 mod 4. So now, let's combine these two results to show what is x squared plus y squared congruent to mod 4. Well, to figure that out, we could split this up into 4 different possibilities. One possibility is both x squared and y squared are congruent to 0 mod 4. Another possibility, x squared is congruent to 0, y squared is congruent to 1. We could have x squared congruent to 1, y squared congruent to 0, or they're both congruent to 1. Okay, so what happens if x squared and y squared are both congruent to 0? Well, then, using compatibility with addition, it follows that x squared plus y squared is congruent to 0 plus 0. 0 plus 0 is equal to 0. So this shows x squared plus y squared is congruent to 0. Another possibility, what happens if x squared is congruent to 0 and y squared is congruent to 1? Then x squared plus y squared is congruent to 0 plus 1. 0 plus 1 is equal to 1, so this shows x squared plus y squared is congruent to 1 in this case. Okay, so then what happens if x squared is congruent to 1, y squared is congruent to 0? Well then, x squared plus y squared is congruent to 1 plus 0. 1 plus 0 is equal to 1. So this shows x squared plus y squared is congruent to 1 in this case. Finally, what happens if x squared and y squared are both congruent to 1? Well then, x squared plus y squared is congruent to 1 plus 1. 1 plus 1 is equal to 2. So we have x squared plus y squared congruent to 2 in this case. So what this shows is, no matter what case we have, it will always follow x squared plus y squared is congruent to 0, 1, or 2 mod 4. But then, according to the uniqueness portion of this result, it follows that x squared plus y squared cannot be congruent to 3 mod 4. Because what happens if x squared plus y squared was congruent to 3? Well then, we would split it up into 3 different cases. One case is x squared plus y squared is congruent to 0. If that happens, then we have x squared plus y squared congruent to 0 and congruent to 3. Well then, by the uniqueness part of this result, it would follow 0 equals 3. Similarly, if we had x squared plus y squared congruent to 1, we would have 1 equal to 3. If we had x squared plus y squared congruent to 2, then 2 is equal to 3. So we get contradictions in each case. So x squared plus y squared can't be congruent to 3. But actually, 2023 is congruent to 3 mod 4. Because 2023 and 3 differ by a multiple of 4. Right? 2020 is a multiple of 4. That's why these guys are congruent to each other. So because x squared plus y squared is not congruent to 3 mod 4, but 2023 is congruent to 3 mod 4, that means x squared plus y squared can't be equal to 2023. And so that's it. This shows if x and y are arbitrary integers, then x squared plus y squared cannot be equal to 2023. So we have proven there are no integers x and y such that x squared plus y squared is equal to 2023. And so this completes the proof. Now, we could really just replace 2023 with any integer that is congruent to 3 mod 4. right? That's really what allowed this to work, right? So the same thing is true for 2019, because 2019 is congruent to 3 mod 4. So it's pretty much the same thing. You just write 2020, or you write 2019 is congruent to 3 mod 4. You get x squared plus y squared is not equal to 2019, right? So yeah, that's pretty much it for this video.